Hello, my name is José Oliveira and today I'm presenting a master's thesis from 2018 with the title Investigating Semantic Similarity for Biomedical Ontology Alignment, which was written by Isabella Mott. This presentation aims to provide an overview of this thesis, particularly of its objectives, methods, results, and conclusions. So, research in the biomedical field has been taking advantage of the use of ontologies to store and organize the large amount of data and knowledge that has been produced in the last decades in this field. And this means that there are many ontologies, often more than one for the same domain, and each one with a vast and differentiated vocabulary, which causes an heterogeneity issue. Ontology matching, on the other hand, tackles this issue by finding bridges of knowledge that link two equivalent or related concepts from different ontologies to help further increase interoperability between different data sources, as well as enhance the existing knowledge. But because of the ontology's large sizes, matching systems use fast lexical algorithms to produce preliminary alignments, and those are later extended by more complex algorithms that often use poor approximations of semantic distances between concepts. And so the main goal of this thesis is to create new algorithms that explore semantic similarity as an extension technique for ontology matching. So, regarding methods, to confirm this hypothesis, the author developed two kinds of matchers: equivalence matchers, which aim to link two equivalent concepts, and subsumption matchers to link two hierarchically related concepts. The equivalence matchers need as input two alignments. One will be the anchor for the extension of the alignment, while the second will have a lower threshold for mapping acceptance. Each anchor mapping will be the starting point for a search for new mappings on its neighborhood, and then new candidate mappings will also be looked for in the second input alignment. One very important aspect of this algorithm is also that it takes into account parameters for three separate dimensions, which are structure, semantic similarity score, and the matcher's own weighting mechanism for semantic similarity scores. And this gives the algorithm some adaptability to different types of ontologies. The comparison between obtained mappings enables the computation of a final semantic similarity score, which, if above a certain threshold, produces a new mapping. On the other hand, the subsumption matchers work in similar ways, but instead of looking only at the neighbors of a possible mapping candidate to infer new mappings, it maps ancestors and descendants between both of the input alignments to infer hierarchical relations. That is to say, if two entities are mapped together, the algorithm swaps their ancestors and descendants and computes semantic similarity scores to look for hierarchical relations. Regarding results, to evaluate the performance of the two new matchers proposed in this thesis, the author used datasets originating from the Ontology Alignment Evaluations Initiative's tracks that have manually curated reference alignments and thus enable the assessment of a given ontology alignment. These matchers were included in the Agreement Maker Lite software pipeline, which is a robust and top-performing ontology matching system. Regarding the equivalence matcher, an overall evaluation showed that the best parameter combination depends on the characteristics of the ontologies being matched. When compared to the baseline, which is a simple lexical matcher, the results show that there is an average increase of 0.2% in F measure. But with the full AML pipeline, no significant improvements were achieved, probably because AML is a top-performing ontology matching system and is hard to improve. But, in contrast, the comparison of the new algorithms to other top-performing systems from the LogMap family show that even without background knowledge, the proposed approach on the baseline can surpass LogMap, which uses background knowledge, by 11.3% on F-measure results. Therefore, the algorithm is able to find correct mappings in the neighborhood it searches for. On the other hand, for the subsumption matcher, it was also evaluated through a manual evaluation that showed between 75.9% and 95% of the new mappings found were correctly labeled. The subsumption matcher, although it was not possible to validate it with a full reference alignment, manual evaluation results show that it is effective in finding actual hierarchical relationships between concepts from two ontologies. And so for conclusions, in this dissertation, two major contributions were achieved. First, the development of a general algorithm for equivalence matching, which is parameterizable to conform to different types of ontologies. and in second place, the development of an algorithm for subsumption matching. The main conclusion of this work is that semantic similarity can contribute to ontology matching in the extension of existing alignments, and that using semantic similarity to extend high-precision anchor alignments can be a valid option for ontology matching in domains where background knowledge is unavailable or difficult to explore. Thank you for your attention.